So we looked at input devices, we looked at output devices, we looked at memory, we looked at, and now we're looking at secondary storage. So this is basically the last category of hardware that we'll be looking at. I think the rest, yeah, from that point, from next week or the other week, depending on how long this chapter takes, we'll move on to software. So today we'll be looking at what is secondary storage. We will be looking at the types of secondary storage and basically the different media that would fall under that type of storage. So hopefully we get to finish everything in today's class. So to get us started, we would like a reader for the first paragraph here at the top. And let's see, Jamal, can you read for us? Jamal? Okay then. Anaya, can you read for us?
Yes, sir. Secondary storage refers to the media and methods used to keep programs, data, and information available for later use. Secondary storage saves programs and data permanently, whereas primary storage uses main memory, which is temporary.
Good. So last week we would have looked at primary memory, which is also called main memory. So that RAM, it stores the information temporarily, because remember we discussed when it loses power, it loses its data also. So because that storage loses its data, we need a storage that would keep data permanently, and that is why we have secondary storage. So that's two features you need to remember there. Primary storage stores the data temporary, and secondary storage stores the data permanently. So can you guys guess some examples of what you think of storage devices that would store data permanently?
Memory card, flash drive.
Good, memory card and flash drive. Anything else? Anything you know that store data permanently?
Sir, DVDs.
A DVD, very good. Anything else you guys can think of? What do you call the other disc compared to a DVD?
CD. CD, sir.
A CD. So DVD, CD, Blu-ray Disc. Sajid mentioned flash drive and memory card. Yeah.
Floppy disk.
Floppy disk, very good. So those are all some examples of secondary storage, because they store data permanently. They don't need any power or electricity in order to store that data. Now let's look at devices and media now. Sharmani, can you read for us? Rambarose? Shamani? Apparently persons are just joining classes and are not in class. Sierra?
Sir, from secondary storage media.
Yes. The two paragraphs.
Secondary storage media. Keep data, instructions, and information on the physical of a computer for future use. Examples are hard disks, compact disks, and tapes. Storage devices record and retrieve data, instructions, and information to and from storage media. Examples are hard disk drive, compact disk drives, and tape drives. So hard disks are storage media, whereas hard disk drives are storage devices. It is very important to have media and methods to store data and programs when a computer is turned off. Secondary storage can be generally grouped into local storage and cloud-based storage.
Good. So, there are two terms here that you need to remember, and that is storage devices and storage media. We would have covered that since in chapter 1.1. There is a difference between a storage device and a storage media. The storage media, it's simple at the bottom here. The hard disks are like the storage media. Those are the physical parts that actually store the data. So the media is what stores the data, but the storage devices are the devices that put the data onto the media. It records that data on the media, or it retrieves that data from the media. So if you were to draw a diagram so as to represent that, it would look something like this here. So if you think about it, when you have your CD or your DVD, in order for the computer or even your DVD player to read that media, you have to put it somewhere. So say for example, this is your CD drive or your DVD drive on your computer, and it has an opening something like this here, and you would either press a button or the eject key on your keyboard, and a tray would pop out from your computer, and in that tray now is where you would put your CD or where you would put your DVD. So we have a CD here, and so this is going to be your storage media, and this is going to be your storage device. The storage media goes into the storage device, and then that storage device now gets connected to your computer, and that is how all of the songs that are on the CD gets read by the computer. So for just in case, for those of you who may not know, this is an example here of a CD drive. It's basically, the storage devices are basically any device that would accept the storage media. So this device here is accepting the CD drive so as to read and write that data onto that CD or DVD. Right, now when it comes to secondary storage, we have two groups of secondary storage. We could either have local storage. So when you hear the word local, what does that mean?
Sir, often used.
Often used, like the physical location. When you hear local, physical location, is it far? Is it near? Is it close by? What is it? No one knows.
Sir, close by.
It means it's close by. So local would mean something close by, something near. So like your local corner shop or your local supermarket, something in the area. So when we say local storage, it means that the storage is basically near us or is not too far from us. It might be in a computer inside of our house or in another room. Basically, it's inside the same building. So it's nearby. But cloud storage now is basically like the opposite, you can say. It is storage that is maybe anywhere in the world. It can be in another town, in another village, in another country. It can be anywhere. So that is what cloud storage is. So we'll get into more of it now. So let's see more about local storage. So Jamal left the class. Sharmani, are you with us now?
Yes, sir.
Okay, can you read for us? Local storage. Shamani?
Yes, sir. I kind of see the picture. It's not coming up.
Can you see it now?
No, sir.
Anyone else having that problem?
No, sir.
No, sir.
Alright, just in case, I'll stop screen share and I'll share it again and see what happens. Good, you should be seeing it now.
Sir, I still can't see it. Wait. Yes, sir. I can see it.
Okay. Local storage?
Local storage. Local storage involves user having storage devices or media with data in their possession or generally knowing of their location. These local storage devices include magnetic media such as magnetic tape and hard disk, optical disks such as CD, R1, CD-R, DVD, and Blu-ray, flash memory.
Good, you can pause there.
Magnet,
So
pardon me, sir?
you can pause there. So local storage is, as I mentioned, it is data that is nearby. So it can be data that is in your possession. So you physically have that data on you, or it is you generally know where the location is, either somewhere in your room or some other room or somewhere. You know the location. Now, when it comes to local storage, there are three ways basically, or three means that we can store these data by. So there are like three categories of storage. So we have of local storage. So we have magnetic media. So basically, if you look at the first word, it tells you how the data is being stored. On a magnetic media, the data is stored magnetically. On an optical disk, the second category is optical disks, and the data is stored optically. And in the last category, we have flash memory, and that data is stored on flash devices. So let's get into a more description of each kind of storage. So first we'll be looking at magnetic storage. We'll look at how it stores data and some examples of magnetic media. Right. So Anicia, can you read for us?
Sir, from magnetic media,
Yes.
the cheapest way to store and backup data is on magnetic media, such as a magnetic tape and hard disk. Magnetic tape. Backing up to tape is vital for computer networks and organization for businesses, which need to store important and large amounts of data for a long time. Magnetic tape is a narrow strip of plastic coated with ferrous oxide. The data is recorded along the length of the tape, with each symbol encoded in binary form across the width of the tape. It is unique since data can only be retrieved in the same order in which it was. Therefore, retrieving the 50th piece of data means accessing 49 pieces that preceded. The tape drive winds the tape from one reel to another by passing the tape over a magnetic head to read, write, or erase the data as it moves. Magnetic tape is used primarily as a backup storage medium, since access to data is not as rapid as with other storage devices. Since creating a tape backup is a slow process, it is often done at night or at the end of a working day.
Very good. Trying to get an example of a magnetic tape. Oh, we have one right here. So this here is an example of a magnetic tape, and I don't know if you guys ever saw maybe a cassette or a VHS cassette we used to use back in the days. Any of you ever saw that? Or ever used?
Yes, sir.
Yes, sir.
Yes, sir.
You would know it looks something like this here. It's like two wheels, and the tapes are wrapped around them. And the tape would either go to one side of the wheel, depending on which direction you're going. So depending on which direction, that is which wheel would get filled up. So let's go it piece by piece again. So a magnetic media. So once again, there's a lot of features that you need to remember. There's a lot of disadvantages, advantages that you need to remember. So an advantage of magnetic media is that it's cheap. So businesses, organizations, they can use it to back up data. So because it's cheap, they can use it a lot to back up data. So that's why they make use of magnetic media to store and back up data. Anybody has an idea what we mean by backup data?
If it say like if you shut down your computer, you could get it back.
Okay. Any other suggestion?
Sir, it can be a case in which you're changing devices and you need to switch the data or use an email address on your new device to get the old data back.
Okay. Yeah, something like that. Like how you back up WhatsApp messages, or you back up the information on your phone to switch device, something like that. So in computer now, we work with a lot of data. We have a lot of spreadsheet, we have a lot of Word documents, and so on. So organizations now, they need to keep all of this data. So they would back up this data or basically store it somewhere else. So basically they're going to be like two copies of the file. So that one is going to be what the business is working on, and in case that goes bad, the backup copy or the copy that you stored somewhere else can be used. So now an example of a magnetic media, remember magnetic media is the category of the storage, of that local storage. An example of that magnetic media is a magnetic tape, and it is used in computer networks by organizations to store large amounts of data, as I mentioned, to back up all of that data. Now, just like a cassette, a magnetic tape has a narrow strip of plastic, as you can see in the image, and notice that the data is written in binary form. As remember, the computer reads the information, reads data in binary. So what is written on that tape is written magnetically in binary. So what's the two digits that make a binary?
Zeros and ones.
Zeros and ones. So zeros and ones are written across the width of that tape. Notice here, it's written across the width of the tape. So the data is across the length, but the binary coding is across the width of that tape. Now, the disadvantage you can say of a magnetic tape is its speed. So you cannot access data quickly with a magnetic tape, because as it says here, basically a tape, you have to access its data sequentially. What that means is that you have to access one after each other. So if you have 50 pieces of data on that tape, in order for you to access the 50th piece, you have to look at piece number 1, piece number 2, piece number 3, and continually until you reach the 50th piece. For those of you who would have maybe used a cassette or a VHS cassette, if you wanted to go to a certain part of that cassette, you have to fast forward, and you would hear that the cassette is actually reeling that tape onto the other wheel so that it can get to that part of the cassette, of the tape. So that's the disadvantage there, the speed. So anytime you want to access the data, it has to basically move that tape to that location so that you can access it. Now the magnetic tape has a magnetic head, and that is what it uses to read, write, or even erase the data. So the magnetic head should be, I'm guessing, this part here at the top. Yeah, that looks like the only thing I'm seeing. Right. So because the magnetic tape is so slow, it is basically used for backup storage. Because imagine if you were using a tape drive, this tape here, as your main storage. For example, if you how you use your computer, you can click here, you can go into your My PC, you can go into music and find a music file and pick a song. Imagine how longer it would take to do all of that if you were using a tape drive. So that's why it's not really used on a computer to store data so that you can use it regularly. But it is used for backing up for data that you don't need regularly. And because it's so slow, the backup process is usually done at night when persons aren't there working during the day. So, we looked at a lot of information so far. We looked at the difference between secondary and primary. Secondary is permanent, primary is temporary. We looked at the difference between a storage media and a storage device. The storage media, so tell me, this tape here, what would it be? A storage media or a storage device?
The storage device.
Answer storage media.
Tamika is correct. A storage media. You have to remember what the terms stand for, what the terms mean. The media is what you are storing the data on, what actually keeps that data. So this tape here is the storage media. And the device now is the device that would put the data on this media. So something I forgot to mention is that if you look here, it says that examples of a storage device would include hard disk drives, compact disk drives, and tape drives. So notice they all end with the word drives, because that's basically what we call a storage device, a drive. So these drives are the devices that put the data or store the data, write the data onto the storage media. So anytime you see hard disk drive, compact disk drive, anything ended with a drive, that would refer to a storage device. And the actual device that stores the data, that keeps the data, is the storage media. Any questions before we move on? Yes, sir.
No, sir.
Alright, so let's look at another kind of magnetic media. Remember, we're looking at magnetic media. We looked at one, magnetic tape. A hard disk is another example of a magnetic media. So let's see. Narendra, can you read for us?
Yes, sir.
Hard disk.
Hard disk, another common device that stores data in is a magnetic disk known as a hard disk. Although it is possible to add external hard drives, most are inside computers protected by rigid cases. Technically, the hard drive is the machinery that controls the motion of the hard disk, which contain the data. But most people use hard disk and hard drive interchangeably.
Okay, one last paragraph. The bottom here, bottom left.
Hard disks are more popular for use with computers and laptops since they store a large amount of data. Hard disks ranging from 700 gigabytes to 1 terabyte in capacity are now common. External hard disks are now available in capacities and speeds similar to internal disks.
Good. So what you guys can do for homework is research what is the storage size of a magnetic tape, because the notes give you for a hard disk, but the notice they didn't give you for a magnetic tape. So research what is the storage size of a magnetic tape. So a hard disk is another magnetic storage. Alright, let me give you a look at what a hard drive looks like. So this here is what a hard drive would look like. So this here is it with the case. So it's actually covered up. It's sealed pretty well so that you can't get inside. But inside of it, you will see disk. So let me download this image. If you look closely here, you can see about 5 disks here. That's why we call it a hard disk also, because it's actually made up of disks, or we could also say platters. So inside of it has disk, and on these disks, so something like your CD. So basically you can say your hard drive is made up of a couple CDs, but it's different from the CD. And the data is stored on this disk here that you're seeing here. Now, because the hard drive, oh, we even have an example of I don't know why I'm searching for pictures and the book has pictures. The reason why we use hard drive is because of the speed. So you can say that's the advantage over the tape drive. The hard drive has more speed than the tape drive. So that is why in your computer that you're using right now, it actually has a hard drive. And that is what your computer is using to store all of its data. All of your photos, your games, your music, it's all being stored on that hard drive. Now, yes, last week we would have looked at how data is represented. So 700 gigabytes to 1 terabyte, that is the capacity, roughly the capacity around what we have now. You might see like 256 gigabytes still, 256, 512 gigabytes. But because storage is the technology is getting more advanced, we're gonna stop seeing smaller storage and start to see larger storage. Now, a hard drive can be internal, meaning you can have it inside of your computer, but there's also external hard drives. So it can plug into your computer, like if you're plugging in a flash drive, so that you can use it like maybe a backup hard drive to store your data. So we were supposed to continue this table here for homework. Can anyone tell me what comes after 1 terabyte?
Petabyte.
A petabyte. So how much terabyte is a petabyte?
1024 terabytes.
Good. So 1024 terabyte is 1 petabyte. And 1024 petabytes is what?
Exabyte.
1 exabyte. And 1024 exabyte is what?
Sir, zettabyte.
Zettabyte. And 1024 zettabyte is what?
Sir, yottabyte.
Very good. I think that's correct. Yeah, that's correct. A petabyte, then an exabyte, then a zettabyte, and then a yottabyte. I'm hoping everyone got that. I'm going to send 2 images in the group, and hopefully that can help you remember about storage sizes. So let's continue. Right, now, so those are the 2 examples for magnetic media, magnetic tape and hard disk. So the next category basically is optical disks, and we'll look at how optical disks store its data and what are some examples of optical disks. Alright, let's get a reader for the next 2 paragraphs. Monique, can you read for us?
Sure thing, sir. So from optical disk, right?
Yes.
Okay. So optical disks. Optical disks can store much more data than most magnetic media. There are 3 basic types of optical disks. Compact disk drives are also known as optical disk drives because they use lasers to store and read data. You will already be very familiar with one type of compact disc, the audio CD that plays your favorite music. There is, though, another type of CD that is used only with computers. This is known as the CD-Rom, compact disk read-only memory. The CD-ROM allows you to access up to 650 megabytes of stored data.
Good. So now we're looking at optical disks, and it says here that it stores more data than a magnetic media. Now I am a little confused about this statement. I'll have to do some research into it because I'm wondering if they're comparing it to older forms of magnetic media, because currently the hard drive is a magnetic media, and the hard drive has more storage than a optical disk right now. So I'll have to do some research as to why they have that statement there. Now there are 3 types of optical disks and 3 basic types. So compact disks are also known as optical disks because they use lasers to store and read the data. So that's why it's called optical, because it uses a light. Let me see if we have an image before I search for an image again. Alright, give me a second. Let me find an image of what I'm looking for. Right. I think I found one. Right. So note that they're saying here that an optical disc uses lasers to store and read data. But how does that laser store and read data? Well, if you look at this image here, we have an image of a CD. And what happens is that on that CD, the laser would make these indents that you see in here, these patterns on the disc. So they're called lands and pits, LAND and PIT, lands and pits. So basically the cutouts that you're seeing are the pits, which looks like holes, and the surface parts are the lands. So this here is another example of binary, because if you think about it, binary is a 1 or a 0. So if you have something that can represent two values, a 1 and a 0, then that is also binary. It can be read as binary. So the fact that we have a pit and a land, that there can be represented as binary, and the computer can read that and be able to read the music off of this CD. So imagine your song on your CD. This is actually what it looks like. All of these grooves that you're seeing here, these grooves and these land, these pits and these land, that's how your data is stored on a CD. Now, a common type of optical disc is called an audio CD, and note CD stands for compact disc. And notice we have the term here again, compact disc drives. So which one is the storage media and which one is the storage device, for a reminder?
The storage device is the thing that stores the media, and the storage media is the device that lets the storage device stores the media.
So for the compact disc and the compact disc drive, which one is the media and which one is the device?
Compact disk drive is the device and compact disk is the media.
Very good. So another kind of optical disc is the CD-ROM. So notice that same word showed up back again that we discussed in memory. Here, read-only memory. So compact disc, read-only memory. So from last week's class, the read-only memory, it only allows you to read that data. So the CD that you have, you can't put any more songs onto it. You can only read the songs that were already burnt onto that CD. So that's a good example of a read-only device, a read-only memory device. Now these CD-ROMs, they give you up of about 650 megabytes. So that's something you need to remember. 650 megabytes for a CD-ROM. So let's continue. Let's have another reader. Jahim, you can read for us?
Many computers with CD-ROM drives can play audio CDs, but the term CD-ROM is always taken to mean any CD format which stores data rather than audio track. CD-ROMs are read-only media, which means that you can only use the data on the disk. CD-ROMs that contain software or programs are of the right ones, read many, warm variety. They cannot be changed once they are created. This is where the ROM part of their name comes from.
Right, good. So just as I explained, the ROM, it only allows you to write that data one time. So for example, if you want to create your own CD, like if you want to create your CD with your own list of music, you need to be careful as to when you are writing all of those songs to that CD, because you can only do it one time on a CD-ROM. But you can read it many times. So that's where we get this term from, worm. You can write once, but you can read many times. So, Jamal, I didn't get you earlier. Let's see if we have you now. Jamal? Seems you still don't have Jamal. Emmanuel, you can help your friend. Okay, Jamal. Emmanuel? Your internet breaking up too, Emmanuel? His mic won't come on. Nario. Or Naraya. Naraya Prasad. Naraya Prasad. Jikia.
Yes, sir. So I was just about to offer my services.
Yes.
Um, from the major advantage,
Yes.
the major advantage of optical drives such as CD-ROMs is that they can store significant amounts of data. However, they can easily be damaged during handling and from exposure to light, heat, or dust. Compact disc recordable CDR and compact disc rewritable CDRW are types of CD that allow data to be written to stored on disk. However, the data on the CD the data on the CDRWs can be erased. Many personal computers are sold with CDR drives so that you can regularly back up data saved on hard disk.
Okay.
Saved on hard disk.
Alright, read the next paragraph. Alright, let's not go on to that as yet. 'Cause we're still on The next one is about DVD. So it says that the CD-ROM can store significant amount of data. Now that's questionable once again, because you can see over here, obviously, that the hard disk stores 700 to 1 terabyte of data, even more terabytes, 2 terabyte, 4 terabyte, and so on. But a CD-ROM barely has 650 megabytes. So I'm still confused as to what you're saying here. However, the disadvantage of a CD is that it is easily damaged. So if you don't store a CD properly, or if you don't handle it properly, it can be damaged. If it gets wet, or if it has moisture around it, if it's in a moist area, then that disc can be damaged. Now we have some more variants of the CD here. We have CD recordable, and we have CD rewritable, CD-RW. Now if you want a CD that would act basically like a flash drive, so that you can put data, delete data, put data again, that is where you would buy a CD-RW, so that you can read and write data as much as you want. Well, until the CD basically dies. So right, so those are the two differences. So let's look at DVDs now. Akila, did you read?
No, sir.
Okay, can you read DVD?
Sir, I'm reading from digital, right?
Yes.
Okay. Digital versatile discs, or DVDs, are used for storing any kind of digital data and gaming software. They can store much more data than CD-ROMs, enough that full-length feature films can be put on DVD. They're known for replacing the VHS cassette tape, which were used to distribute movies, and as a result, DVDs are often referred to as digital video discs. A DVD, a DVD video holds video programs and is played in a DVD player linked to a TV or monitor. DVD-ROM, like CD-ROM, holds computer data and is read by a DVD-ROM drive linked to a computer. The massive storage capacity of DVDs, coupled with the fact that digital technology produces better pictures, are the main reason DVDs replaced videotapes. Blu-ray discs were designed to replace the DVD by storing several hours of video using a storage capacity of up to 100 gigabytes. Its main use is for distribution of video game software and feature films that can be viewed in high definition resolution.
Good. So DVD stands for Digital Versatile Disc. So, but because it was used basically to replace the VHS cassette, which was used for video, that's why some persons refer to it as a digital video disc. This term at the bottom here. But let's try to use digital versatile disc as the original name, and it is used for digital data and gaming software. So now a DVD can store more data than a CD, because the DVD can store a full length movie basically. So that is why VHS cassettes went away, because they store their movie in basically a lower quality, and a DVD now can store a higher quality video, so that you can basically enjoy the entertainment more. Now so notice these terms here appearing again. So ROM and R, so basically these terms here, RW, R, and ROM, you will see them alongside CD, DVD, Blu-ray, and so on, and they basically mean the same thing. If you see ROM, then it is read only. And if you see RW, it means you can read and write data to that media. Now, another form of optical disc is the Blu-ray disc, and it's basically replacing the DVD because it can store more data than the DVD. What you guys can do is research what is for homework. Research what is the size of a DVD because they have I don't see them mention it here. They mention the size for a CD, but they haven't mentioned the size of a DVD. And there's also sizes for the Blu-ray disc. I think the table at the bottom has it. Yeah, the table at the bottom has it. So you guys don't have to do that. The table at the bottom has it. Right. So Blu-ray is replacing the DVD because of its larger storage capacity. So basically anything that has larger storage capacity will always begin to take the dominance, or will always be replacing what has smaller storage capacity. So because of its large storage capacity, and its physical smaller size, it can be used for storing video games or very high definition resolution movies and so on. So we're gonna pause here for today. Next week we're gonna continue with flash memory and then cloud storage, and then we'll look at the table. So till next week you'll get your homework here. So basically you have no homework for this week. But that doesn't mean you have no work, because next week I'll be requesting a video from everyone. That video, you are making a video of all of the notes that you would have written so far, that you should have been writing so far. So I would have given you 1.1 basic computer components. You should have written that. I would have given you 1.2 basic input devices and media. Should have written that also. 1.3 output devices and 1.4 primary. I would have said you are allowed to print 1.5 secondary storage. So basically that's your breaking point until you get into writing the rest. I'll see what I allow you to print from that also. So basically in the video, I should see notes on 1.1, 1.2, 1.3, and 1.4. You don't have to make the video lengthy. Just the video should be like if you're taking pictures of the page, but don't stay too long on the page. Let it be a short video, so maybe 1-2 seconds on the page, so that I can see the content on the page and be able to know if you're actually doing work. Yes, what is the question?
Sir, about the drawing. Sir, can you print them if you can't draw?
The drawing, you don't have to be perfect with the drawing, so try your best to see how you can draw it. I prefer you draw it because that'll help you to remember it more.
Sir, I missed the 1.4 notes. So they might be a little out of place in my book, a little out of order, but and I have to print them too.
Once you have all the notes in your book.
Okay.
So the scores that you gave us last week, that is for the Christmas term, or do we have more things to do?
That is for the Christmas term, and yes, you have more to do. So those of you who
Sir, but the rest will be added to that?
So will it affect your overall grade? So if we're doing good now and we get 97% and we do bad in the next test, is our overall percent gonna drop?
Yes, it will. So that's why you have to continue doing good. It's a you can say it's like a benefit for the persons that aren't doing so well right now because they actually need it more, and it's gonna motivate the persons who are doing well to continue to do well. Right. So in review, today we looked at secondary storage. That refers to permanent storage. Primary is temporary. We looked at storage media and storage device. The device is what writes or reads the data, and the media is what keeps that data or what stores that data. We looked at three categories of local storage: magnetic media, optical disks, and flash memory. Next week we'll continue with flash memory. I'll send out the instructions as a reminder in the WhatsApp group. And yes, so if you guys don't have any other questions, you are free to leave. Enjoy the rest of the video.
Okay, sir.
So